Hello Level 2s and welcome to 2.4 Atomic Structure and Bonding, and welcome to Lesson 3 on Shapes of Molecules. So here are our 3 learning objectives for today. It is to name the 3 parent geometries, to name the 3 shapes that are derived from the parent geometries, and to describe the shapes of molecules. So let's get started. So shapes of molecules are derived from Lewis structures. Okay, so that's the first thing that we need to know. That's why we learnt Lewis structures last time. So I'm actually going to take you to some pictures of some Lewis structures to explain the first principle. So electron density regions. So what are electron density regions? They are basically an area within a molecule that's got lots of electrons in them. And because electrons have a negative charge, these electron density regions repel each other as far as possible to gain stability. So an electron density region could be a bonded pair, but it could also be a non-bonded pair. And when we talk about electron density regions, we're actually always concerned with the electron density regions on the central atom. So if we look at this example here of beryllium dichloride, on the central atom there's 1 electron density region and 2 electron density regions, because there's this bonding pair between Be and Cl and this one here. So 2 electron density regions, and I'm going to do EDR every time because it's much easier for me to do. If we look at this one here, okay, there's 1, 2, 3 electron density regions. There's no lone pair on the top of B, so there's just 3 electron density regions, and they all happen to be bonded here and here. Okay, here's another one. 1, 2, 3, 4. So this is 4 electron density regions, and so that all of them would start repelling. Let's look at ammonia. 1, 2, 3, 4. So 4 electron density regions as well. If we're just comparing these two, they've both got 4 electron density regions. However, ammonia's got this lone pair, but because there's electrons here, they're going to repel these electrons just the same. So that's why it's 4 electron density regions. Okay, water. 1, 2, 3, 4. Again, 4 electron density regions, and they're all going to repel. Doesn't matter if that's a lone pair or bonded pair, they're all going to repel. And then this last one here is a little bit different because there isn't actually a central atom. So there's kind of just 2 electron density regions, but this one's a bit funny because there's no central atom. Okay, so hopefully that's made sense so far, and let's carry on with the learning. Okay, so at level 2, there are 3 parent geometries. And a parent geometry is a shape from which others are derived from, and that's why it's given the term parent geometry. So the first of which is a shape that you will have seen many a times, and that's actually tetrahedral. And I'm going to get you to make some of these when we do our interactive game on Teams, and you can see here's my model here. So I have got a ball in the middle, and I have got 4 bonds coming from it. And each of these bonds are at a bond angle of 109.5. And the reason why it's 109.5 is purely that's the area where each electron density region can repel as far as possible, creating stability. And when we go online at Teams chat, I'll show you how you can make this, and we'll do a wee game. So first of all, tetrahedral parent geometry, okay, there are 4 electron density regions. These are repelling as far as possible, and it creates a bond angle of 109.5. Okay, so that's tetrahedral. It's your first parent geometry. Your second parent geometry is trigonal planar. Okay, it looks like this. Circle with 3 bonds coming off it with a 120 degree angle between the pairs here. This is a planar shape, and what we mean by planar is it lies flat on the plane of a page. So I can actually lie it flat on my hand here, okay, because it's planar. All right, so that's 120 degrees. There are 3 electron density regions that repel as far as possible. And if you split a circle into 3, the bond angle would be 360 divided by 3, so 120. And that's what we've got here as well. Okay. The last parent geometry is linear. Okay, where you've got a central atom, and on either side, you've got 2 bonding. And this gives a bond angle of 180 degrees. In this one here, there are 2 electron density regions. Okay, So there are 3 parent geometries, and all of our other shapes are derived from these 3 parent geometries. There's no easy way around it, folks. You have to memorize these names. So you have to learn that tetrahedral has 4 electron density regions, trigonal planar has 3 electron density regions, and linear has 2 electron density regions. And we're going to do various activities to help consolidate that for you. But that's the first lesson, okay? So now, these are not the only shapes, there are actually 3 more, but they're actually derived entirely from these parent geometries. So I'm going to bring back those shapes that I've just been showing you, and we will learn those. So this is when there is a lone pair. So you will have seen from Lewis structures that you could have, like in the previous example before, we had methane and then we had ammonia. So methane had 4 bonding, whereas the ammonia only had 3. So I'm going to show you ammonia now, an example with 3. If I just take off this top bond here, okay, this is actually a shape called trigonal pyramid. Trigonal pyramid, where the top one is a lone pair. Okay, so a lone pair. It's still repelling because remember, this is an electron density region, this is an electron density region, this is an electron density region, and this is an electron density region. So they're all repelling each other, okay? But we can't actually put anything here, which is why I've taken off that top bond, because there is no other atom there. However, because that lone pair is contributing to the repulsion, that's why the shape is still holding true to the bottom half of that tetrahedral shape. So this is called, when there's one lone pair, this is called trigonal pyramid. Now trigonal pyramid, because it's got the 4 electron density regions, is derived from that tetrahedral shape. And if we remember, that tetrahedral shape had a bond angle of 109.5. By the way, when we talk about a bond angle, it is between bonded pairs. So this bond and this bond are at 109.5 degree angle. Okay, so that's your 4th shape. So if you've got 4 electron density regions and one of them's a lone pair, we take off the top one there, and that gives us trigonal pyramid. It's called trigonal pyramid because if you put a bit of paper over top of all of these bonds, it would look like a pyramid that had a trigonal base. Perfect. So that's your 4th shape. So now we're going to talk about our 5th shape. Now our 5th shape is actually also derived from that tetrahedral parent geometry. So if I take off another bond here, and there's 2 lone pairs of electrons. Now this is the example of water. Then you end up with this shape here. Now this is actually a planar shape. The last 2 that we've just done, the tetrahedral and trigonal pyramid, they were both 3-dimensional, and I'll teach you how to draw those. The rest of your shapes are planar, which are nice and easy. So you say phew to that because much, much easier. So this is a planar shape. This is known as bent or V-shape. I don't call it V-shape. I only ever call it bent. Okay, and it's planar. And just to recap as to why it's planar, it sits in the plane of the page. So I could lie that flat on my hand, okay, and it lies flat because it's planar in line with the plane of the page. If my hand was a page, then it would be lying flat. So this is bent, and you guys have seen this shape so many times because you've seen pictures of water since you're probably in year 9 or 10, and it's just never linked to a shape name. So there are 4 electron density regions still, so 1, 2, 3, 4, because there are 2 lone pairs, and they're all repelling each other as far as possible to gain stability. So these 2 are contributing to the shape, but they're just not included in the shape because there's literally no atom that we can put there. So that's why 4 electron density regions, and it still holds that bond angle of 109.5 because they're all repelling each other as far as possible, and so therefore this bond hasn't changed. It's still 109.5, and when we talk about a bond angle, it's always between 2 bonded pairs. So we would say that this structure has 2 bonding pairs of electrons and 2 non-bonding pairs of electrons, and therefore the shape is going to be bent. Okay, so we've actually got 2 shapes that are derived from our tetrahedral parent geometry. So we've got, if I add a bond again, we've got trigonal pyramid. If I take off another one, so 2 lone pairs, we've got bent. And if I put all of them back together, we have got tetrahedral, okay? So bond angle of 109.5. So there are 3, just to summarize, there are 3 shapes that have a bond angle of 109.5. That is because there are 3 shapes that have 4 electron density regions. So we're now going to go on to the last shape, which is going to be our bent shape. Now you've seen that before. That's crazy. What is that? So actually, if you hold up your trigonal planar shape and you take off one bond, it doesn't matter which one, then you'll notice that it then creates the bent shape again. So what's different between this bent and the bent that I held up before? And it's actually the bond angle. So the bent from tetrahedral is 109.5 bond angle, whereas though the bent from trigonal planar is 120 degrees. And that's because this bent here is derived from the parent geometry trigonal planar, because there are 3 electron density regions that are all repelling. Okay, so it's derived from this trigonal planar shape. One of the bonds is a lone pair, which means it is now bent, 120 degree bond angle, 2 of them are bonding and 1 is non-bonding. So that sums up our shapes so far, team. So there are 6 shapes you need to learn for level 2. There are 3 parent geometries, so they were your tetrahedral with 4 electron density regions, your trigonal planar with 3 electron density regions, and your linear with 2 electron density regions. If there are lone pairs, then these are still derived from those parent geometries, so they have the same bond angle, however the name is different. So if there's one lone pair with 4 electron density regions, it's trigonal pyramid. If there are 2 lone pairs with 4 electron density regions, it's bent. And if there's one lone pair with 3 electron density regions, it's bent. Now folks, no easy way around it. You're going to have to memorize those names. So try and do that as quickly as possible, because everything kind of relates back to this lesson. So just some examples here that you can see. Okay, we don't actually draw lone pairs when we draw a shape, which I'll show you in a second, but you can see here there are 2 bonding pairs. Okay, don't worry about this column. I'm just going to cross this out. I never worry about that. There are 2 bonding pairs, 0 lone pairs, so the shape is linear. Bond angle 180. If you've got BCl3, there are 3 bonding pairs, 0 non-bonding, so therefore it's trigonal planar 120. Methane, 4 electron density regions, 4 of them are bonding, 0 non-bonding, tetrahedral 109.5. Ammonia, 3 bonding, 1 non-bonding, making a total of 4. Okay, you'll see here that this bond angle is slightly less than 109.5. In NCA, we just say 109.5. This is actually correct, and if I was with you guys in class, I would explain why that is, but I'm just going to forget about that for now. If people are still interested, I can explain at a later date. And same goes with this one here, 2 and 2, that gives a total of 4, so we're going to put that as being 109.5. It's not technically correct, but that's the answer NZQA at level 2 are accepting, and I can explain a bit later why that would be. Now, because there are 2 and 2 here, it's bent, and because there's 3 and 1, it's trigonal pyramid. So hopefully that's made sense. So let's just have a look at this exercise and see if we can work out the number of electron density regions and therefore the shape. So this is CO2, so we're looking on the central atom. 1, 2, that means the shape's going to be linear, and both are bonding. This example, 1, 2, and 3, that means it's going to be trigonal planar, all bonding. How about this one here? 1, 2, 3. So these are 3 electron density regions. 2 are bonding and 1's non-bonding. So they all contribute. So it's derived from trigonal planar, but that lone pair means it's going to be bent. This one here, 1, 2, 3, 4 electron density regions. They're all bonding, so it's going to be tetrahedral. This one, 1, 2, 3, 4 electron density regions. They're all going to repel. 3 are bonding, 1 is non-bonding, so it's going to be trigonal pyramid. And the last one here, 1, 2, 3, 4 electron density regions. They're all going to repel as far as possible. You've got 2 bonding and 2 non-bonding, so it's going to be bent. Hopefully that has made sense. Questions to me on Teams if it doesn't. Cool, so I'm actually going to pause here and we'll do lesson part B on this, which is explaining the shape for your NZQA exam.